Welcome back to our lecture series on gradients, divergence, and curl. So in this video, we are going to be looking at directional derivative. So we are going to be looking at the formula to calculate the directional derivative and then some examples to understand the application of the formula. Alright, so now let's get started. So let's say given that the function is phi. Exactly. Given that, let's just take it can be, they can name it anything. You can have it as function A, function B, function whatever. So, but let's just give it as function phi. So for directional derivative, will be, so let's just, this is just a representation of what directional derivative is. Then it will be equals to the grad of phi, that's of the function itself, and the dot product of A. So I'll explain what A means. So where A, okay, let me just write it somewhere down. Where A is equals to capital A over the magnitude of A. Now, so where A itself is the direction of vector A. Now, this direction of vector A will be given in the question over the magnitude of direction of, okay, of vector A. Exactly. So this the formula to calculate the directional derivative. Exactly. So we are going to look at one example now so that you can have a better understanding on the application of this formula in calculating directional derivative. So let's look at example 1. So here's the question. It says find a directional derivative of phi, which is a function, and the function is given as x square y plus y square z plus z square x at the point 1, minus 1, 2 in the direction of the vector A, and this is the vector A. Exactly. So now let's do this together. So again, this is the formula. So now let's look at let's look for all of the values that we're going to need. So the first thing that we can decide to calculate is grad phi. Grad phi, exactly. So let's calculate grad phi. So for grad phi, so if you have been following this video series on, I guess you'll be familiar with this by now on how to calculate the grad of a particular function. So this is the formula here, partial differentiation. So this is partial differentiation, j plus k, exactly. All right, so let's do the partial differentiation of phi with respect to that of z. I mean x. Okay, so if you have to differentiate this with respect to x, that will be, this will be 2xy, this will be 0, and this will be z squared. Okay, so let's go ahead and write that down. So 2xy plus z squared I. All right, so I'm just going through it through this grad file real quick because we've looked at up to more than 4 or 5 examples on how to calculate this. So if you have watched the previous part, I want to believe by now you won't have any problem. But if you missed those parts, kindly just go to the playlist of engineering analysis, and then you're going to find all the examples that we've looked at under gradients. Okay, so if you had to look for the partial differentiation of the function with respect to that of y, so that will give us, so this will give us x squared, and this will give us 2yz, and then this will give us 0 because we are not having any y in it. So let me go ahead and write it out. So like I said, you're going to be having x squared plus 2yz j. Okay, So also for that of z, so let's go ahead and look at it again. For this now, this is going to be 0 because there is no z here. For this, we are going to be having y squared, because if you differentiate z, it's going to give us 1. We'll be left with y squared. And if you differentiate z here, to give us 2zx. Alright, so let's go ahead and write it down. So this will be y squared plus 2zx, then k. Alright, so again, let's go back to the question. It says at point 1, minus 1, and 2. So just like some of the examples that we've looked at earlier. So that means, where are you? So that means our x is 1, minus, okay, our x is 1. So that means our x is 1, our y is minus 1, and our z is 2. So let's substitute those values into what we have here. So for this, so this will be 2 times 1 times minus 1 plus z squared is 4. So with this now, we are going to be having minus 2 plus 4. So that will give us 2i. Why this is going to be x squared is 1 plus 2 times our y is minus 1 times 2, which is 1 minus 4. And that will give us minus 3j. Okay, so if you are finding value in this, please give the video a thumbs up. So for that of z, we are having y squared, which is going to be minus 1 squared plus 2 times our z is 2 and our x is 1. So this will give us 1 plus 2 times 2 is 4. So that will give us 5k. Alright, so we can just conclude that our graph file is 2i minus 3j plus 5k. Alright, so this isn't our final answer yet. So what we've just gotten is this. Exactly. So the next thing we need to calculate for is our a, and we've been given that the formula for a is this. So let's go and do that now. So again, we already know that our a is a over the magnitude of a. Okay, so from the question, we are given what a is. So you can see that this is the value for a. So that means our a is 4i plus 2j minus 5k. Are we good? So now let's calculate the magnitude of a. So calculating the magnitude of a will be 4 square plus 2 square plus minus 5 square. And if you should simplify this further, it will give us 16 plus 4 plus 25. So 16 plus 4 plus 25, if you calculate that, that should give us square root of 45. Are we good? Okay. Alright, so now we can go ahead and calculate our directional derivative. So again, the formula again is, so the representation is this, which is equals to the grad of phi, which is the function, multiplied by a. Alright, so, okay, before writing, okay, since I've written it already, so let's just establish our a. So, our a, so our a is 4i plus 2j minus 5k over square root of 45. So this should be rewritten as 1 over root 45, then into bracket 4i1 plus 2j minus 5k. Exactly. So make sure you put it in this form so that it will be easy for you to find the dot product. Okay, so now we can go ahead and continue with calculating the directional derivative. So our directional derivative is equals to now. So let's see what's our grad of phi. We got it to be 2i, which is this 2i minus 3j plus 5k. So let's write that out. 2i minus 3j plus 5k. So let me just put this in brackets. And the dot product of a. So the dot product of a is 1 over 1 over root 45 in brackets 4i plus 2j minus 5k. Are we good? Alright. So to make it much more explanatory, let me just rearrange this. So let me just rearrange this as, so let me just make the a should come first. Exactly. So let me just write this as 1 over root 45 into brackets 4i plus 2j minus 5k. So that means what is I'm having here, I want it to come first with the dot product of 2i minus 3j plus 5k. Alright, so now we are going to do dot product here. And in doing dot product, 1 over root 45 will remain. Now remember that when you are doing dot product, so this will go ahead and multiply this. Exactly. So 4i1 multiplied by 4i multiplied by 2i will give us 8. Exactly. So once you are doing dot product, the I, j, and k, those coordinates will no longer be there when you are dealing with dot product. Exactly. Then, so the next one is 2j will go and multiply minus 3j, and that will give us minus 6. And then minus 5k multiplied by plus 5k, and that will give us minus 25. Alright, so if we should simplify this now, we are having 1 over root 45. So 8 minus 6 and minus 25, and that will give us minus 23. So we can write it as minus 23 over root 45. Okay, so if you point that in your calculator, minus 23 over root 45, let's see what that will give us. So minus root 23 divided by root 45. So that will give us minus 3.43. And this is the final answer. So we can just conclude that our directional derivative is equals to minus 3.43. Yeah, 3.43, not 45. Okay, so that's just example 1. In the next part, we're going to be looking at example 2 again. So just in case you're still confused, just try and just go through the video again. I try as much as possible that I don't skip any important line. Exactly. So just go through it again from the beginning, understand the formula. So to make it much more easier, you can just rewrite the formula as this. Make the a come first. So you can just have it as a directional derivative is a multiplied by the grad of phi. Exactly. So that once you get to this point, so that once you get here, you don't need to start rearranging. Alright, so I hope you find value in this. If you do, please let me know in the comment section. If you are yet to subscribe, please go ahead, click on that subscribe button. You see it at the lower right of your screen there. Just click on that subscribe button. And with that, I'll see you in the next part of this video. We are going to be looking at another example under directional derivative. Thank you.